Hello everyone, I'm Reza Tangestani, and in this video I'm going to teach you Abaqus in less than an hour. If you are an absolute beginner and you want to start learning Abaqus, this is the best video that you can find, because in this hour you will learn from the beginning how you will learn how to create a model and how to run a model. I'm going to start from the part model, okay? And here you can create your part. By creating on here, you can rename your part. You can define it as a 3D or 2D or anti-symmetry. And then in 3D, you have deformable and these options, okay? Deformable are the common option for creating a part, but discrete rigid and analytical rigid are for creating a rigid part. Okay, discrete rigid is the for parts that are complex and you need to mesh them, but analytical rigids are for parts that are very simple geometry wise. I mean, for example, a spherical or a cuboid. And earlier I'm not going to talk about it's advanced. Solid, shell, wire, point. These are the four type of the part that you can work on. We usually use these, and then in shell you can design a 2D part in the 3D. I mean, for example, if you want to create a plane on the top of the part, you can define this. And wire is for creating, for example, a line or wire or a pipe. You can use this option. But point is just a point, and it's not very common to use point in creating part. Okay. And after clicking on this, you can create your part by selecting, for example, you have the different option, circular, rectangular, and ellipsoidal. And by clicking 2 point, you can create a rectangle. And after that, by clicking on done, you can define a depth for it, for example 20, and then you can see your part. Okay, one more time. If you go on 2D, we have shell, wire, and point. Okay, we cannot define the 3D in 2D shell. So if you go with shell and then click on it, you can define a rectangle, but by clicking you're gonna see a 2D plane. Now I would like to define one more thing. Here, when you go on 3D, you have a number here. Okay, if you put 200, okay, and then click on continue, and you put the first point in the center, and then the second point on the one for x direction and 0 on y direction, you're gonna see something like this. You see it's very small compared to our Eurospace. Okay, I'm gonna go out of it, but when I click on it and then I put 1, for example, or let's say 10, for example, and then I put the same value, 0 for center and 1 in x, 0 in y direction, you can see it's bigger than that one. So it's kind of acting like a lens in microscope. So by changing the value, you can scale your model. Okay, and then just want to define that. And after that, if you have, for example, this part, you wanted to add another geometry to it, you can click on it and then click on here. It needs a vertical on right or vertical on left, it doesn't matter. So if you click on this line, it's gonna show you this face, so you can create a part on it. Okay, again, then I'm gonna say okay, done, and it gives you it asks you for a depth and the way of the extruding. I'm gonna say blind, and the depth is 6, and then you can see this one. But if you want to define a shell on top of it, for example something like this, and then I create something like this, and here I think then you put the depth for it, you're gonna see something like this. Okay, and if you want to cut the part, you can use this option, extruded cut, and after that you create a rectangular in the middle of it. Done. Again, throughout or blind. Throughout means to the other surface, to the last surface. Blind means that you need to define a value. So you can see it's cut at the part. You can define fillet by clicking here, and then uh, defining radius. You can define fillet. The other options are a little more complex. I'm not going to talk about them. But the other important thing is defining surfaces and datum, a partition. For example, for partition, if I go and click on it, I would prefer to always go with two options. One of them is this one, cutting the plane surface, and then selecting point and normal, and then click on here, and then a line, and then you can see it cut into the half. Okay, but the other one is creating a face. For example, I'm going to go to the face, and then I click on here, and after that I click on the right at the edge of the part and create a surface on it, and after that I said done, and in here I go with this option. I select this one, and I select edges by pressing shift, and there it says extrude along which direction, which is this one, and then you can see your part is cut it. Okay, probably you ask why do we need partition. Partition is very good for having a good mesh. You need to create partition your parts, so you can create a better mesh for your parts. So if you have very simple geometry, you don't need it, but if you have a more complex geometry, you might need to use partitioning. Okay, the other thing is that you can create a reference point. Reference points are usually for rigid bodies, so we don't need it. You just need to click on the point and assign the whole property to a point. So for rigid body, you need to have a rigid reference point. And also in the datum, you can define the points. For example, midway 2 point, you can define this one and this one, and put a node. It define a node on here. You can define axis, principal axis, or these are good for partitioning and creating parts. So, but the only way that you can learn these are from practicing. But in the purpose of this video is to give you an idea how to use Abaqus, not the advanced Abaqus. Okay, I'm gonna stop it here. Going for the next one, which is part. Okay, the next step is defining the property, material property. But before going, I would like to create a part. 3D deformable solid extrusion. Good. By that, I define the depths. Okay, and in the property, you only need to assign these three. First of all, it is important to define your material. Okay, you can define your density, you can define your elastic modulus, for example 209 and 0.3 for Poisson ratio. You can define your plasticity, 300 is 6 and 0. Okay, these are for mechanical model. If you want to create a thermal model, you need to define conductivity, for example 300, and specific heat 300, and you already define the density. It depends on your model and the study that you're doing. You need to define the material properties. So by clicking on OK, we need to assign this property to the part. By this, you can create a section, and then it was homogeneous, and then it's OK. The other one is assigning the part. Okay, if I click on it and then I said this, it turns, and you need to create a section 1, it turns to green. Okay, for each part you need to assign the material property. For example, but for the plate you need to assign it as a different way. For example, if I create it on this, I need to define it. It's not solid, it's not 3D anymore, it's a shell. So you need to do this, and then homogeneous, and then you need to put a value for depth. In every part in real life is a 3D. So, but whenever we define as a 2D, we ignored one of the directions. So we need, but it doesn't mean that we don't have it. It means that it is constant. The properties are everything, or the stress or the variable is constant in that direction. But we need to define a value for it. So I'm going to say, for example, 1 in here, and you can increase the thickness integration point for more accuracy, but it's not necessary. You can use the material properties, same material properties, or different one, it's okay. And then you can assign it to the here. That's it. You can we have it now. And next one is assembly. In Okay, in assembly you can put your parts. For example, if I click on here and then click on this one, I have two options, dependent and independent. The only difference in the way that you create mesh on it. So if I click on independent and I go to the mesh, I can mesh it from here. Okay, but if I go on here for part 3, I cannot mesh it. Okay, but if I made it dependent and mesh, if I made it dependent, I would be able to do that. Okay, if you have, for example, two part of it, and then you wanted to move these, the first one to here, you can easily click on here, pick the first point and the second point, and it moves the first point to the second point. For example, again, if I want to move this part from I want to move this point to here, I just need to click on here to here, and then you can see it. Okay, and if I need to rotate it, I can use this option, and for example, align this axis about 90-degree. You can see it's very easy, but I don't need it now. I wanted to delete it here. For assembly, this is the most part of it, and but there's important note that you should notice. You should consider that whenever you do partitioning on part section on here, you see it is different from partitioning on here. So if you do partition on part, you can see it on assembly, but if you do partition it in the assembly, you cannot see it in part section. So it's on. You should consider this point. The next one is a step. A step is the way is the part that you need to define the way your model. Okay. If you click on here, you can see you have plenty of options. You can have dynamic, explicit, implicit, and static general. I'm going to define a few to introduce you a few of them. For example, a static general. If you click on it, and then you have two options: NLGM on and off. If you have plastic, if deformation is large, you need to turn it on. I personally prefer to turn it on in many cases. Time period is the time that you need to create your model. If your process is happening 1 second, you put 1, or 2 second 2. Fixed or automatic, right now it's a little more complex. It's a little complex to use fixed, but you put always on the automatic, and you can have a maximum number of increment, and for here it is the initial and minimum and maximum. I'm not going to go in detail, but just to give you an idea, always put the 10% of the total time. Okay, and it's ready to go. But sometimes we need to do explicit or implicit modeling. So if you go to implicit, same things happens here, but you have options on here. It's not important. Always go with the default option. I might talk about it later, but the default option of Abaqus is fine here. Same things in here. Again, I would recommend to put the 5% or 1% of the total time on here. Don't touch these. They aren't very important, but you need to know them to learn to understand how do you modeling them. This is okay. For this part, this is very advanced. In 99% of time, you don't need to touch this. Okay, this is for dynamic implicit. But if you wanted to go for explicit, you need to go explicit, and then NLGM on, time period, interaction, increment. You don't have that option, but you can create mass scaling. If you know mass scaling, it's good, but if you don't know, I would recommend to see our and the others videos. You can put the value in here, and it's mass scale by 3. That's it. But I would recommend you to learn the weight of mass scaling. Okay, it's not important for here. I'm gonna go with the static general. I'm gonna replace it here. I'm gonna go here, static general, and 10% of the total time. Everything's good. In here you can define the value of that you want. It doesn't matter you check them or not. The only difference in your solution is that you want to see the results or not. For example, if you're doing the thermal model, you will not have any stress in your model. Okay, so you will not see this. You will not see this option. So, but if you have a mechanical model, you will see this, but and after solving the model you will have the residual stress, the stresses during the process. But if you want to see this in your results, in your output file, you need to check this. If you don't check it, it doesn't mean it doesn't consider the stress. It calculate the stress, but it won't will not show it to you. This is the way that you can save the results, a frequency. For example, if you put every two increments show you the results, and there are plenty of options you can use it here. The history output is not as important than the field output. This is mostly important for explicit method. I'm not going to talk about it in here, but it's good to know that there are some output that you can use it for all. For all your model. For field output, these are the output that they are related to your increments, but these are related to the whole model. And now I'm gonna go to interaction. In interaction, you can define the contact or the other stuff that you want. For example, if you go and create an interaction, you have surface to surface contact, self contact, general model change, and the other stuff. For surface to surface contact is between two parts. For example, if you have a tire on this asphalt, you need to define it, and then you need to create a slave and a master. This, for example, the first one is master, the second one is a slave. So you click on slave and then you can click on it, but we're not gonna use it. But if you click on it, you're gonna see this, and after that you need to define the property. For example, we need to create the property of the contact. If you create here, you can go tangential behavior, normal behavior. In tangential behavior, you can define it as a frictionless or considering the friction between two surfaces. In normal behavior, if you have a material or that another material go through it, for example a ball into the water, you need to define it and define the viscosity of the second material, and then you can define. But if you put hard, it means that it's not gonna go through the thickened part. Okay, and then you can click on it and go for it. But the other option is the general contact, self contact, which is, for example, if you have a machining, you creating a model for machining. When the tool cutted the part, it might happen that this portion of part contact with itself. So you need to define self contact. So when it touches this surface, it doesn't go through the material, through itself. So and it because of that, you need to define the self contact. There are other options like tie and rigid body. If you want to define this as a rigid body, you can use this option. Coupling is for creating momentum, and tie, if you have if you want to attach two parts together as like welded, you can use tie, and then you can define a surface. But it's not gonna happen here because we don't have two parts. And you can create and you can say okay, that's it. But we don't need this because it's very simple. We only have one part here. I just wanted to show you how you can use this. I'm going to remove these. Okay. Then this one, just to wanna make sure that you understand, this one was for creating the property for contact. Okay. Everything's good for now. Also, I would recommend that you can define inertia, crack, or the other spacing or constant and every other properties in this part as well. Now we can go for the next part, which is defining the load. And load, you have, for example, in mechanical model, you can define this concentrated force or pressure. Concentrated force is a load on the single node. For example, on here, if you put a value, you can see the value, the direction of the force. And if I put the pressure, and here you can see a value, you put the value, you can see a load on top of the surface. Okay, and then after that, there are many options on here. You can use them. Body force is mostly like a gravity, but on different direction. We usually use these two. We don't use the other option more often. And always you need to constrain your part. You need to define the boundary condition. These are the options. You can fix your part from a point. For example, in here you can see the definition of the loads. For example, if I put anti-symmetry, fix it from every direction, but if I put it here, it's defined, it's with constraint from x direction and two other rotational direction. I would go to if there are more options, for example, displacement or rotation. If you want to pull your part from this node in x direction about a very small value, I need to do that, and it's gonna do this, and it's gonna pull the part from here. The other option that I have is speed. This is the constant. This is the pull. It pull the part with the constant value, but this one is pulling part with, or moving the part with a constant velocity, and you can define the acceleration for it as well. It's okay for now. And you also can define the predefined. For example, predefined temperature, or in here we only have predefined temperature. But if you change the step, you can define the temperature, material, or whatever you want. Okay, just remember, whenever you create a step in here, I'm gonna close this. Whenever you create a step, you can add another one next to it, and then you can define different load in different steps, move to the right. It means in the first second, each one is 1 second. We define, as if you remember, we define 1 second for each. In the first second, it's gonna pull the part from this part with this value, and then in the second it's gonna put this pressure, but the first second it's already constrained here. In this exactly in the first second it's already constrained here. uh, it's gonna start pulling the part from here, or I can say, okay, move it to the right, so it's start moving from the second and move it to the left. This one, no, it's not gonna happen. So it's gonna constrain the part from the whole time. Okay, and then I'm gonna go to the mesh part. I already created mesh, but if you want, I want to describe it. You have two options. You can assign a single value for all part. You can, for example, by decreasing this value, you can have a finer mesh, and then you final node, and then by clicking on it, you can create it. If you hold it, you have the different option. For example, this you can remove the mesh, and then I want to show you how the partitioning works. If I go here into the part and then create a partition by tool, partition, this one, point and normal, selecting the point and the normal vector on it on the plane, you can see it's cut the plane. The cutting plane was defined like this. If I go to the mesh, I can see my part. I can create the mesh separately now. For example, or I can use this option to define the different value for each edge. For example, if I do this, and then I have different option. None, it means that 10 elements for each edge. Single, it means that in one direction it increases the distance between each node. Or double, you can see it in the middle, it decreases but in the edge it decreases the distance, but in the middle it increases the distance. If I can click on it, and then here by click on here, you're gonna see this changes. Okay, for same for here, you can remove the constraint on your mesh and then mesh it again. Okay, and in here you can define your type of mesh. It's all it's by default defined as a 3D stress for a standard. You can have reduced integration point, or you can click on it or not. This is a very advanced definition. I would recommend you to learn use our other videos for this part. And then everything is good for here. We don't need to change it, but for thermal model you definitely need to come here and change it to a heat transfer model, heat transfer element. Okay, and here you can assign mesh. For example, it's a little bit complex. I would create another video for this part as well. It's a it's a mesh technique, but you don't need it for the simple models. And after that, you can jump from it. You don't need to do it's advanced. You can go and create your job. But before doing that, I would recommend you to go in here and set your directory file, and then click on OK, and now you're good to go. By doing this, you will put your all output in the one directory. Now and click on here, create a job. You can create a model name. Here is job, continue. You can change the number of processor. If you have subroutine, you can put it in here. It's advanced, you don't need it now, and then you can submit it. But I'm telling you, if we submit the job now, we're gonna face error. Let me show it to you. It's not gonna last long. As you can see, the log started, and you can see it says too many attempts. Okay, the other purpose of this video was showing you how to debug your problem. First of all, you need to deactivate your all condition. For example, this if I click on here, I'm gonna see this one, and then I'm gonna deactivate this one. Actually, I want to put this one too, and then here I'm gonna deactivate this, and I'm gonna run it again. So the first step that you should do, deactivating some of your boundary condition or some of your loads. Okay, now we're waiting a little more. Okay, again you can see it's happened. So which means that there is another problem that we haven't still figured out. So we go to the step, we can see that this one is a little weird. Okay, imagine this, you point holding from the point and then you extend it from the other point. It doesn't make sense, a little bit tricky. So the way I want to do that, so I want to change the boundary condition. I'm gonna pick it here and then click on it, and then going to here and again submit it in. You see the job has been completed, and now we can see the results. Okay, but these results is not the result that we wanted to see. We wanted to see with those loads that we already deactivated. So we're gonna go to here and activate one of the loads, this one for example. So and then we again go and submit the job. Last time that we did it with this condition, it didn't work. But now we are trying, because we already figured out the boundary condition that was a problem. We're gonna check it now again. Monitor, yeah, it's completed again. So we are free to go one more step ahead. We're gonna go to the load again, and here we deactivated this part. We're gonna activate it now. Submit it. As you can see, the job is running, but you can see a few attempts in the in between, which is not, it's pretty much normal. It's not a big deal. Um, Now you can see it's completed. So we will figure it out. We find out that the problem was for the boundary condition. Down here it was a wrong boundary condition. So whenever you wanted to debug your model, you should remove everything. I mean, even you need to define a simple geometry and then start from the beginning. And after that, step by step, run the model and to see where was the problem. In this our problem, it was the point. And now if we can change the question or the problem, we can define the boundary condition like this. If we cannot, we need to define the boundary conditions the way that it doesn't make our model stop. So, and now we can go and see our results in here. First I need to click on here and then I can see the results. It's not a very normal model. I just wanted to show you how the Abaqus works. By clicking on here you can see the video, and then by here you can control the video. And also if you want to see the result from a point, you can click on here, and then for example you can go centroid, and then for example stress mices, then you can pick elements. The centroid is means that the element, the stress is getting from the center of the element, and then you can plot it and you can see the stress. Also if you want to check the value in the specific time, for example in here you wanted to see the results, you can click on here prop value, and then by putting on the, for example, nodes, this is the stress, you can see the values. For example, this is the value, so you can see. Okay, and that's pretty much all of it. Okay, thank you very much for watching this video. I promise next time I'm gonna make another video about the more details of the Abaqus. This one is just talking about the general of using Abaqus. I hope you enjoyed this video. Until the next video, bye.